As you know, in the layered architecture of IoT, Internet of Things, this component networks comes at the bottommost layer, or it is in the layer 3, or the sensing layer of IoT. So this particular session is focused on component networks. So myself and my student Jay Suraj will be sharing this particular session. So I will give the introduction and I will hand over to Jay Suraj. Jay Suraj is doing PhD in the area of IoT. He is working in the area of routing on IoT network. So he will be handling most of the part, 80% of this particular session will be handled by Jay Suraj. So this particular lecture is divided into 3 parts. First part is on the basics of IoT. So this will give you an introduction and just give a motivation for the whole session. And second part is on component networks. That is the layer 3 of the IoT architecture. And at the end, we will also be discussing about how to set up an IoT lab in an institute or an university. If you'd like to have an IoT lab, what are the essential components to be included in the IoT lab, that will be covered. And we will be mentioning, or we will give a list of conferences, top conferences in this area, and the journals where you can get a lot of useful information in this particular area. That is also listed in this talk. And finally, the open challenges or the research problems existing in this area. I'm sure there are research scholars, or most of you are either faculty members and you have students who would like to do PhD or research in this area. So this open challenges part, or that section of this talk, will be focusing on the unsolved research problems or unexplored research areas in the field of IoT. So coming to the basics, so just give an introduction. So what is the current scenario of Internet? So Internet technology has been evolving ever since its inception. Now, even in this pandemic situation, people are surviving, or we could communicate each other only because of this technology called Internet. So sitting from Kerala, I could talk to the people at West Bengal, the faculty members and students of West Bengal, through this powerful medium of Internet. So without Internet, we cannot think of living today. People can survive without electricity for a few minutes, but if there is no Internet connection, you won't be able to tolerate, or you won't be patient enough to handle a situation where you are out of the net. So in the year 2010, the number of Internet-enabled devices per person went above 1 for the first time. So during 2010, the total number of IT-enabled devices has gone higher than the total number of human beings on the Earth's surface. It is estimated that the number of such devices, IT or Internet-enabled devices, may go up to 4 per person by the year 2022. So the total number of Internet-enabled devices will be 4 times the total number of human beings on the Earth's surface. That is actually the prediction. Estimates also suggest a 3-fold increase in the annual global IP traffic. So as more and more devices are getting connected to the Internet, the traffic is also increasing. As we know, I'm sure Kolkata is probably one of the cities in India where you face a lot of traffic congestion because the roads are narrow, or we are not getting that many number of new roads, or the infrastructure is not increasing, but the number of vehicles are increasing. The same way in the Internet also, the number of Internet-enabled devices are increasing day by day, or we can say hour by hour. People are adding more and more devices into the Internet. So naturally, the traffic on the Internet is getting increased like anything. Machine-to-machine communication, M2M connections, are likely to account for 51% of the total by 2022. That is again a prediction. which is a sharp increase from the value of 34%, which was existing in 2017. So these predictions are from Cisco Visual Networking Index 2017-2022. So we are facing a situation where the number of internet-enabled devices are increasing like anything. So what contribute to such an increase in the traffic? Let us see the reasons. Such an increased traffic can result in severe scalability as well as traffic congestion issues in the internet. Just like we talk about traffic congestion on the roads, there is traffic congestion on the different gateways in the internet. The reason behind such an estimate is the ever increasing number of IP enabled devices. So by the year 2022, as I mentioned already, the total number of IP-enabled devices is supposed to reach about 4 times the total population at that time. A solid reason behind this increase is the latest innovation, which allows even everyday things to get connected to the internet. The innovation called the Internet of Things. So today we know we are talking about the things getting connected into the internet. Anything that is available on the earth's surface can be hooked into our internet, the network of networks. So any device which is having a sensing capability and which is having a communication capability and which is having a computing capability can be connected into the internet. So that is actually the situation today. So if you have a device which is having a communication capability and which is having a computation capability, you can think of connecting or you can think of hooking it into the internet. So Internet of Things this is IoT is regarded as the latest and trendy innovation in the information and communication technology or ICT domain. IoT can be defined in simple terms as the inclusion of everyday things in the global internet platform. So let that be a working definition for this particular session. So IoT can be defined in simple terms as the inclusion of everyday things in the global internet platform. So two salient features of these things, the two salient features of IoT are the things should be able to communicate among each other with minimal or no human intervention. So the things that you are connecting into the internet can communicate each other with minimum or no human intervention. Things are designated as the end users. So these are the two salient features of this IoT. IoT has been realized as a result of constructive fusion of multiple technologies. So wireless sensor networks, internet are all some of the technologies which are contributing to the fusion of, or IoT is actually a fusion of all these technologies. So let us see what is the impact of IoT in the society today. What distinguishes IoT among other innovations in the ICT domain is its unprecedented social relevance. So we know internet is already part of our life. So IoT has also become part of our society, an essential component of our society. So the complete realization of IoT can be indeed passed on numerous benefits to the society. Some of the areas where IoT has already shown its role or its is playing its role are the healthcare industry, the smart homes and smart cities, food security and sustainable agriculture, secure, clean and efficient energy and transportation systems. So let us look into some of these areas, some examples which will motivate us to attend or to know more about this particular technology. So we know IoT can be used in shopping or in the modern shopping malls. IoT can play a very big role. So when you go to a shopping mall, after your shopping, when you go to the checkout counter, you may find a very big queue there. You have to spend a lot of time in a queue. So mostly none of us or nobody is ready to stand in a queue and spend a lot of time, because time is very, very valuable. So you would like to check out immediately, or you would like to pay the bill immediately. So IoT can play a very big role in automated shopping or automated checkout. When you take the different items from the shopping mall, the sensors or the devices can automatically find out which item you have taken and what is the price. And when you come to the checkout counter, automatically the total bill can be charged to your bank account, and it can be deducted automatically. So that is actually possible through the use of IoT. And there are smart shelves, as I was mentioning. When you take the item from the shelf, automatically it will identify which item you have taken, how many quantities of that item you have taken, and accordingly the bill can be generated automatically. So that is actually one area where IoT can be, or we find people using IoT. There are even shopping malls where there are no human beings and everything is fully automated. I mean, everything, the whole shopping process is automated. Unmanned shops are also there. Recently in Cochin, in Kerala, they have started a shop where there is nobody as such managing the things. I mean, as and when the things are getting over, the shop owners will just fill the items in the shop. That's all. IoT in healthcare. In healthcare, IoT is playing a very, very vital role today. So we know for patient monitoring, for patients who are in the ICU or in the emergency care unit, IoT devices or sensors can do a lot, contribute a lot in monitoring their vital parameters. Tracking the location of a medical equipment, that can also be done using IoT. And in ambulance services also, IoT is playing a very, very important role. As you know, when a patient is, I mean, when somebody is found ill or he is not well, or there is an accident or something, the from time of that accident to the time at which he is reaching the hospital is very important. So that is a very critical period. So the moment he is entered into the ambulance, if the doctor can connect or the hospital can connect to the ambulance and see the condition of the patient, they can do all the preparations or they can do the preliminary checking while the patient is in the ambulance itself. So there are smart ambulances which are actually, which can connect to a nearby hospital, and the doctors in the hospital can see the patient when he is in the ambulance itself, and by the time the patient reaches the hospital, they will be ready with all the necessary equipments, all the surgeons, and all the, they will be doing all the preparations so that when the patient reaches in the hospital, immediately uh, the surgery or the treatment process can be started. So the diagnosis to a large extent can be done when the patient is in the ambulance itself. So that is actually the smart ambulances services, which many of the hospitals are trying to offer through these IoT enabled ambulances. Now, food security and sustainable agriculture, that is very important. Agriculture is very important for any country. Even India has realized the importance of agriculture. So smart farming and precision farming, all of you might have heard about the term precision farming. Precision farming is something which is an IoT enabled agriculture method. So the live tracking of the weather and the environment is possible with the help of IoT devices. Selection and harvesting the crops. So by knowing the weather prediction, and by testing the soil, by getting the predictions about the behavior of the soil, you can decide what type of crop you want to put in the next season. So in the monitoring the crop health, by sitting in at your home itself, the farmer can watch the health of the crops. So that is possible. Monitoring the soil nutrition level and water content. Water is also very important. I mean, watering, the proper watering of the plants can be controlled, and it can be managed with the help of sensors or IoT devices. So that is another area where IoT is playing a very major role. IoT is very playing an important role in agriculture. And of course, this is another one which all of you are familiar. Now people are talking about, and people are have started realizing these driverless cars. So in a city like Kolkata, when you are driving from your home to your office, I mean, lot of your time is getting wasted when you are driving, because it is a very difficult exercise to take your vehicle safely to the office when there is heavy traffic. So most of your time, the daytime, the quality time is lost in the on the roads while driving, and by the time you reach the office, you will be very much tired also. That is why people are talking about automated driving. I mean, driverless cars. So you sit in the car, you just type where you want to go, and then you can involve in your office work or your academic work right from the car itself. So this is actually possible, or this has already many cars have come on the road in many of the European countries, which are actually the driverless cars. That is actually a very big example of the application of IoT. So the tracking I mean, when you are talking about a driverless car, it is actually a very serious application, because you have to track other devices or other cars which are in front of your car or on your. I mean, you have to keep safe distance. You have to prevent accidents. You have to make your vehicle ultimately smart. So the smart vehicles or automated driving or driverless cars is an area, a big area where IoT has been applied today. So here you can just see in this picture the different technologies which are used, the fusion of technologies which are making these driverless cars a reality. Okay, from now onwards, we are going into the technical side or the internals of the IoT. So we will see the architecture of Internet of Things, and there from there we will go to the component networks. And I'm handing over to my student Sri Jay Suraj for taking this session from now onwards. Over to Jay Suraj. Thank you. Jay Suraj, please.
Sir, am I audible?
Yes, you are audible.
Okay. Thank you, sir.
I shall stop sharing my screen so that you can share your screen. Yeah, you can share your screen and start, Jay Suraj.
Okay, sir. So, sir, is the screen visible to all?
Just a minute, it is coming. Yes, Jay Suraj, it is coming.
Okay.
Visible.
Okay, sir. So, I'm starting, sir.
Yes, please. Please proceed.
Okay. So, till now, we have seen what are the basics of IoT from an application perspective. So, which or what are all the opportunities provided by the IoT, which or in which or way IoT can benefit the society. All these things we have seen now. Now we have to see the IoT from more of a technical side. So, let me begin with an explanation or a brief introduction on the layers in the IoT paradigm. So as noted here, that they are grouped into the different enabling technologies are grouped into three layers. So actually we can say that the three different layers of IoT corresponds to the different enabling technologies. So as noted here, the layer one, that is the bottommost layer in the picture, that is called the sensing or the perception layer. So you can see in the figure that this is the layer where things reside. We all know that IoT is characterized by everyday things. So these embedded devices or sensors are present in the sensing layer. So we can say that it is the backbone of this entire IoT paradigm. It is on top of this that other layers are built. Now the next layer, that is the network layer or the layer 2. That is the middle layer in the figure. So in the network layer, it is actually providing connections between the gateways, or we can say that it is the layer which provides the connectivity in a backbone network. That is what is known as network layer. So sensing layer is regarding end networks or user networks, and in the network layer it is regarding the backbone networks. And the topmost layer is the application layer. Application layer means this is the layer where various IoT applications are realized with the support of network layer and sensing layer. So in the case of application layer, we will need to apply a lot of data analytics techniques and cloud computing techniques. So that is the concept of application layer. So these are the three layers in the IoT paradigm. This is a just introduction to these three layers. Now we can see yet another representation of IoT layers, and this time it is actually a detailed representation, but it is the same. It is actually the same. It is actually the same as that of the previous figure. So here the only difference is that it is more elaborate. For example, the first two will be the sensing, the next two will be the network, the final three will be the application. So it is actually the same figure but in more detailed manner. Okay, now we can give a small introduction on what actually this presentation talks about. That is the component networks in the IoT. As noted here, IoT networks correspond to the network of things or sensors present in the sensing layer. So while explaining the figure, I have already told that things are present in the sensing layer. So these things actually will form a network of its own. That is, it will form a network of things, which is ideally a sensor network, and this network is connected to the internet. And these individual networks are known as the component networks of IoT. That is actually called the component network in the IoT. Now, you must be careful that this should not be identified with the network layer. So since or even though we are talking about the component network, it is not actually about the network layer of IoT. I am not talking about the normal network layer of either ISO OSI model or TCP IP model. I am actually talking about the network layer of IoT paradigm. We have seen that in the network layer of IoT paradigm, it is mainly concerned with the backbone network, not the component network. So the component networks are not present in the network layer in the IoT. We should not misunderstand like that. Therefore, component networks are present only in the sensing layer and not in the network layer of IoT. Be careful that it is not present in the network layer of IoT, not TCP, IP or ISO OSI, but it is not to be identified with the network layer of the IoT paradigm. So these could be networks like RFID networks, wireless sensor networks, etc. So we have seen that different component networks are present in the sensing layer, and these component networks can be of any type. It can be very simple RFID networks, or it can be wireless sensor network. Even it can be smart vehicle network, as you have seen in the slide regarding IoT in transportation system. So all these things could be a component network in the IoT. Now these networks are connected to the internet through the appropriate gateway. Okay, now that I don't think needs more explanation, because it is anyway part of the IoT, therefore it should be connected to the internet. If the networks are not connected to the internet, they are just standalone networks. They won't be a part of the IoT. So in order for the network to be part of the IoT, these should be connected to the internet, and this can be done only through the usage of appropriate gateways. Now we can see the concept of component networks in the sensing layer of IoT in more detail. Okay, so out of the three different layers, some more explanation will be given in the case of sensing or the perception layer, that is the bottommost layer. This is because this is the layer where component networks reside. So as said, this layer or the sensing layer is important considering the fact that things which denote the characterizing feature of IoT reside here. So without things, Internet of Things is merely Internet. So Internet is transformed to Internet of Things only because of the presence of things. And these things, or the base or backbone of the IoT paradigm, reside in the sensing layer. Things can either get attached to the internet directly, or they can form a network and then attach to the internet through a gateway. So there are two ways by which these things can become internet or IP enabled. The one method is that things can directly get attached. Like when we turn our Wi-Fi on for mobile phone, it will get attached to our modem. So that is one possibility. And there is another possibility, that is, if there are more everyday things, they will form a network, and this network will be attached to the internet through a gateway. And this is known as the component network of IoT. Low power and lossy networks, or LLN, is a major enabling technology in this layer. So we have already seen that a lot of enabling technologies together is responsible for the development of IoT as a paradigm. So in the sensing layer, the major enabling technology is the low power and lossy networks. We will discuss about the low power and lossy networks in detail in coming slides. So often referred to as the IoT aware networks or the internet aware networks. So the low power and lossy networks are often referred to either of these two terms, either IoT aware or internet aware, because once it is connected to the internet, it is also responsible for the traffic coming from the internet. So it is actually a part of the global platform, global internet platform. Therefore, it is often referred to as either the IoT aware network or the internet aware network. So we can see a brief introduction regarding the radio frequency identification, or RFID. We have seen this term in the previous slide, that RFID networks can be a component of the sensing layer in the Internet of Things. So this can be said, RFID can be said as the founding technology for the IoT paradigm. This is because this was the most, earliest form of the concept of things communicating with each other. So it can be said as the founding technology. So in that time, the idea was to use RFID tags in accordance with the electronic product code. So this is actually similar to the barcode which we are seeing while buying the commodities. We know that there is a barcode attached to the commodity. All the details regarding that commodity will be entered to the barcode, and then that can be read using barcode reader. So similar idea is there in RFID also. A global item identification represented by the EPC was assigned to each physical object. So we know that in the case of IoT, things are the main component. They are not systems or the normal computers. So these things should be given proper ID. In the case of internet, so in the case of traditional computers, there is IP address. All those identifiers are there. But in the case of things, identifiers should be given, and that was standardized by the Electronic Product Code, or EPC. And these identifiers were stored in tags directly attached to the objects. So this figure shows an example of a tag, and these tags will store all the identifiers which are associated with a thing or a physical object. So this, I have included this in the slide because this is actually the most oldest form of things communicating with each other, or we can say that this is the most oldest technology in the sensing layer of the IoT. Or we can also say that RFID is the oldest component network of IoT. Now we can move on to the next step of evolution, that is the wireless sensor network. So when compared to RFID, we are more often hearing the term of wireless sensor network. It is actually more popular when compared to RFID as a component network of the IoT. So WSNs, or wireless sensor network, can be considered as the next step in the evolution of IoT. So after RFID, wireless sensor networks are considered as the next step. Traditional wireless sensor networks were designed primarily for data acquisition. So I hope all are familiar with the architecture or the topology of a wireless sensor network. In the case of a wireless sensor network, there are mainly two classes of nodes. There are sync nodes and there are source nodes. Source nodes are the component nodes and the sync nodes are responsible for gathering this information from other nodes. So it is actually designed for data acquisition. Traditional wireless sensor network. But in the context of IoT, wireless sensor networks contain actuators along with sensors. Therefore, it is often referred to as the wireless sensor and actuator networks. So, for the time being, you please note that in the case of wireless sensor networks within the IoT paradigm, there is another component known as actuator in addition to sensors. The role of actuators and sensors will be discussed in a future slide. For the time being, you just note that it is often referred to as wireless sensor and actuator network, which is often abbreviated as WSAN. Okay. Now, attempts were made by the researchers to integrate RFID and WSN based on the EPC framework. So this is actually natural. We have seen that RFID networks were the most oldest form of component networks in the IoT, and wireless sensor network marks the next phase of evolution. So it is natural that the researchers tried to incorporate these two because some of the physical objects or the things might be embedded with RFID technology, whereas some other things may be embedded with wireless sensor technology. So if we are going to create a paradigm known as IoT, which enables all the things to communicate, these two primary or the most oldest technologies should be combined. Then only IoT can be realized. So various attempts were made. Now we can see how integration of RFIDs and the wireless sensor network with the internet was done. So as present as given in the slide, there were two methods. One method is integration at the object level and the second method is integration at the system level. First, we can see what is integration at the object level. The solutions, that means the solutions under integration at object level. The solutions consider resulting nodes as either RFID tags equipped with sensors or as wireless sensor nodes with a unique ID. So these are two solutions. First solution is either RFID tags are equipped with sensors. So what can you understand from that? It is essentially an RFID network. The RFID tag is equipped with sensors. That is what is the first solution. That is combination of RFID and sensors have been done, but it is essentially an RFID network. Or the next solution has wireless sensor nodes with a unique ID. So here it is actually combination is taking place, but it is essentially a wireless sensor network. So these two solutions were considered. The former method has the advantage of not being has the disadvantage of not being able to support direct communications between the nodes. The former method means the solutions considering RFID tags equipped with sensors. So what will be the disadvantage? You know that when we go to shops and see barcode readers and all, can two barcode readers or can two commodities communicate with each other just because of the fact that they are given barcode tags? They cannot. The tags can communicate only with the help of a barcode reader. Just by the presence of barcode, two commodities can never communicate with each other. So that is the case of RFID also. So if it is essentially an RFID network, as in the first solution, any two devices cannot communicate directly. An RFID reader will come in between. Therefore, device-to-device communication is not possible in that level. And you have seen in the introduction slide by Madhukumar sir that the number of machine-to-machine communications is going to account for more than half of the total traffic. The machine communication means device-to-device direct communication without any intermediary. So that is not possible in the case of first solution. So that is not has not been developed much. Now the second method, that is the second method where it is essentially a sensor network. The second method has the advantage of using wireless multi-hop communication procedure. So in that case, it is essentially a wireless sensor network, and therefore it can use the normal sensor network or wireless network routing. There is no problem in the case of device to device communication. So considering these two, we can say that the second method is more advantageous. So you can also see why wireless sensor networks have become more popular compared to the RFID, even though RFID was the first one. This is because machine to machine communications, which are so vital for the future internet scenario, is rather difficult in the case of RFID networks. So that is the reason for the more popularity of wireless sensor networks. Now that is all about integration at the object level. Now we can see integration at the system level. In the case of integration at the system level, you just understand that it uses a gateway in order to do the integration, that we can explain using a figure. So this figure shows how a system level integration can take place. So as shown here, there is a wireless sensor network here. So these wireless sensor network will have different sensor nodes, and this is actually different RFID tags. And these RFID tags will get connected to the internet through the readers, and wireless sensor networks will get connected to the gateway and then go to the internet. And the gateway or these edge devices are responsible for the translations which are required for the interoperability between wireless sensor networks and the RFID network. So, from the network part, they need not think about interoperating or the required translations. All those will be handled by the gateways. So this is actually the method which is being used now. All in the current scenario, all kinds of networks can get connected to the internet through the gateways. So this is what is called system level integration. Now we can see standalone networks and IoT aware networks. In the previous slides, we are always repeatedly saying IoT networks or component networks and all. So we can see what exactly is the difference between these two terms. As noted in the first point, both RFID as well as wireless sensor networks have a standalone existence. Standalone existence means they need not get connected to the internet. That I have already said. They can exist even without getting connected to the internet. But only after they have get connected to the internet, they will be a part of IoT. So once they are connected to the internet, they are either internet aware or IoT aware. Both are same terms. We can use either of these two terms. Now we can see which are the peculiar features of IoT aware networks. For instance, take the example like this. If you are considering a wireless sensor network, what are the differences, major differences where wireless sensor networks are having a standalone existence, that is when it is not connected to the internet and when it is connected to the internet. So we can see what are the differences. So the first peculiar feature of IoT aware networks is the presence of actuators. We have seen sensors. Why we have seen that in the traditional standalone network there will be sensors, but when they are connected to the Internet of Things or internet, there will be presence of actuators. But please note that traditional wireless sensor networks can also have actuators, but it is not mandatory. So, but in the case of IoT aware network, or when the wireless sensor network is a part of the IoT, then presence of actuators is necessary. So, what is actually actuator? We have seen that IoT enables things to communicate with each other without any human intervention. That, as Sir said, is the working definition for this presentation. Now, consider a scenario. Suppose you are having a habit of waking up at 6 o'clock in the morning. Then what will you do? You will set up an alarm clock with time set at 6 o'clock. Then suppose you are having a habit of taking a bath in warm water after waking. Then what will you do in the normal case? After waking up, you will switch on the water heater and then you will take the bath. But if it is an IoT enabled scenario, it will be like this. Alarm clock will ring and the sensor in the water heater will sense that the alarm clock has rung and you will come for bath. Therefore, and after that, sensing that the water heater, the actuator present in the water heater will trigger the on switch. Then only the water gets heated. So that is the function of actuators. Without actuators, no action can take place. In the case of Internet of Things networks, one object has to communicate. It is not merely data gathering. One object needs to communicate with another. That is, when one object communicates an information to another object, based on that information, the second object should trigger an action. So in order to trigger that action, presence of actuators is must. That is why I said actuators may or may not be present in standalone networks, but in the case of IoT networks, it will be present. That is the first feature and the first difference. Now the second is the presence of bi-directional traffic. We know that IoT aware networks are connected to the internet. In that case, it is natural that there will be traffic from these networks to the internet, as well as there will be traffic from the networks to the to these networks. Therefore, there will be both traffic in both directions, that is uplink and downlink traffic. So this is another difference. In the case of standalone networks, since it is not connected to the internet, bidirectional traffic or the downlink traffic is not necessary. Now, the different IoT-aware networks are often identified under the term low power and lossy networks. Now, again, you please do not misunderstand that low power and lossy networks are another class of networks which is distinct from wireless sensor networks or RFID networks and all. Any network which comes under the sensing layer or any network which is IoT aware or any component network of the IoT, they are often identified under the term low power and lossy networks. So we can say that in the low power and lossy networks, there can be RFID nodes, there can be sensor nodes, there can be a combination of both. All these will be there. So LLN or low power and lossy network is a general term given to all the component networks. Now these low power lossy networks are classified as resource constrained networks by the Internet Engineering Task Force. Now we can see what is meant by a resource constrained network, because resource constrained network is the most distinguishing feature of the low power and lossy networks. Okay, resource constrained networks, there are two categories. One is constrained network and the next is constrained node network. First, we can see what are the features of a constrained network. So the first feature is that is a low achievable throughput. You know what is throughput? If it is low, what we can say, the network resources are not at all used efficiently. The utilization is not efficient. That is one characteristic. Next, high packet loss. The packets sent from the source, there is no guarantee that it will reach the destination correctly. That is another feature of constrained network. Then highly asymmetric link characteristics. Highly asymmetric means what is asymmetric? In the case of normal networks, in most cases, the different links will have same characteristics or the same strength and all. But in the case of resource or constrained network, each link will have its own characteristics. Some link will have more stability, some other link will have medium stability, and some other link will have very low stability. So different link characteristics will be there in a single network. That is another characteristic. Now the final characteristic, lack of advanced services like IP multicast. You know what is multicast? Multicast means simultaneously sending a packet to more than one destination. Such concepts will be absent here. These are the different features of a constrained network. Now there is another terminology again defined by the IETF known as the constrained node network. In the case of constrained node network, it consists of a significant amount of constrained nodes. That means in this case, majority of the nodes will have some kind of resource limitations. In that case also, it will become a constrained network. That is, a constrained node network is always a constrained network. So if it is a constrained network, it indicates that it is a constrained. So if it is a constrained node network, it indicates that it is a constrained network. But the reverse need not be true, because a network can be constrained even without the presence of significant amount of constrained nodes. It can be due to different network characteristics. So these are the two terminologies. Now we can see the concept of low power and lossy network, or LLN, in more detail. So as already said, it is the major enabling technology in the sensing layer of the bottommost layer, composed of many embedded devices with limited power, memory, and processing resources. So what can you understand from this? In this case, many of the nodes are limited in resources. Or we can say that in the case of LLM, majority of the nodes are constrained nodes. We have seen that when majority of nodes in a network are constrained, it is called a constrained node network, and as a result, it is also a constrained network. So we can say that LLMs are constrained node networks, and hence they are also constrained networks. Now they are interconnected by a variety of links such as IEEE 802.15.4 or low power Wi-Fi. So this is concerned with the link layer. How the links are connected? These, we can say that the links are connected using these low power standards, the standards which are suited for low power devices, maybe like Bluetooth and all. So that is the fact concerning the links. Wide scope of applications including industrial monitoring, building automation, healthcare, environmental monitoring, etc. So even though the LLMs are categorized as resource constrained networks, we cannot just set them apart, because LLMs are the major enabling technology of the backbone layer of the IoT. Therefore, whatever applications are meant to be realized by the IoT, LLMs will have to play a lot of role. So even with all these limitations, it is the duty of the researchers to make it adaptable to suit all the potential applications of the Internet of Things paradigm. So we can see what is the LLM topology using a figure. So in the figure, you just for now ignore the terminologies like UDP and host, RPL nodes and all. That we will come in a future slide. You just understand the components. So here, this blue device is a border router. This border router, to this border router, a lot of things will be connected. This is the network of things, and this is the low power lossy network. So low power lossy network will consist of a network of things, and these things will be resource constrained in nature. And this will be connected to a border router. From border router, it will get connected to the internet. So we can say that thing, as already mentioned in some previous slides, all the things are connected to the internet, thereby LLM becoming a part of the internet, or becoming a part of the Internet of Things. Now we can see the different network technologies used in LLMs. In traditional internet, we know that each and every device may use TCP/IP protocol, but that is not the case in LLMs. We have seen that LLMs can contain sensor nodes, can contain RFID nodes, and can contain both, and also even more some more other technologies. So we can say that we cannot guarantee a unique protocol in all the devices supported by the LLM. Each device may be supporting different technologies, but they will be, the peculiar feature is that even though the different devices in LLMs are following different technologies, they are part of the same network. That is the feature. So multiple networking technologies are used in the LLMs. First, we have already seen RFID, then Zigbee IP, digital enhanced codeless telecommunication, ultra low energy, or DECT, abbreviated like that, Bluetooth low energy, or BLE, power line communication, or PLC. So these are the multiple major networking technologies used in the LLM. So I have already said that the single network will contain all these kinds of nodes. So there should be a medium for interoperability between these different technologies. That is given by another technology known as 6-LoWPAN, which is open or which is expanded as IPv6 over low power wireless personal area networks. So this actually is the outline. That is, multiple technologies will be there in a single LLM, and the interoperability will be provided by 6-LoWPAN. Now we can see each of the networking technology in more detail. I have omitted RFID because we have already seen that in the previous section. So we can start with DECTULE. As already said, it is expanded as Digital Enhanced Codeless Telecommunication Ultra Low Energy. So first we can see which kind of a topology is used. It uses a star topology. You know what is a star topology? That is, a base station will be there at center, and to that all the others will be connected. So that is, all the devices will be connected to a single base station. The devices will not be connected with each other, but the device will be connected to a single controller. That is known as a star topology. So there are two parts, portable part and the fixed part. The portable part means the devices, and the fixed part means the base station or the central controller. So this will be arranged in a star topology format. Regarding the most common applications, DECTULE is used in home security and home health monitoring. That is, it is used within small areas inside a single building, like home security, home health monitoring, and all. So regarding the devices, it is used in smart door locks. It is used in healthcare pendants. The smart door lock means key is actually not there to open it. That the lock will detect the person, and then if it finds suitable, or if it finds safe, it will unlock. That is called smart door lock. Then healthcare pendants. Healthcare pendants is actually getting more widespread popularity nowadays. That is, in the case of patients, they will be given healthcare pendants, and that pendants will have sensing, computing, and communication capabilities. So even if the patient is at home, they can be monitored from a distant place. That is possible. So healthcare pendants, all these devices use DECTULE. Now we can see some of the disadvantages. One disadvantage, as I have already said, star topology is used. Mesh topology is not supported. Star topology, I have said that it is not concerned with device-to-device connection. Device is connected to a common base station, but that is not allowable in the case of current internet scenario. Mesh topology is always better because in the case of mesh topology, each adjacent device will be connected to each other. So it is a guarantee that better connectivity will be provided by mesh topology. That is the first disadvantage. Next is multicast is not supported. Multicast is not supported. Then what will it do? It will do multiple unicast. Multiple unicast means, suppose there are two destinations, say A and B. If there is multicast, data will be sent to both A and B simultaneously. But if it is not there, first it will be unicast to A, and then it will be unicast to B. So in that case, multiple unicasts will be performed, and it will result in a lot of energy wastage. So these are primary disadvantages of the standard of DECTULE. Now we can see the second network technology used in LLM, that is Bluetooth Low Energy, or BLE. It is useful for devices transferring small quantity of data at low rate within short ranges, that we all know. We are always using Bluetooth either in our smartphone or the laptop and all. It is actually used in short ranges. It uses two channels. This also I think you will be familiar, like Piconet and advertising channel. Piconet means it is concerned with communication of already component devices, and advertising channels allows even more devices to get connected to the network. So these are the two channels. This is same as that of the traditional Bluetooth. That is why I am not going to the explanation. So frequently used in home automation, health and fitness, and proximity applications. Again, it is used in short ranges. The devices include smart car keys, body sensors, smartphones, etc. Here, smartphones we are all familiar. Smart car key is similar to smart door lock. When the driver comes, it will get unlocked. Otherwise, it won't get. There is again now manual key. That is called smart car keys. Then body sensors. Now there is another term which I think most of you will be familiar. That is called the body area sensor network. Body area sensor network is actually a variety of wireless sensor network. In the case of body area sensor network, multiple sensor network devices will be attached to a single body. That is, to a single body of a single patient, multiple devices will be there and they will communicate. So in designing such devices also it can be used. Then scalability issues form the major disadvantage of PLE. That also it is natural because since it is operating within short ranges, there is a limitation for the number of devices which it can accommodate. Considering the scalability issues put forward by the IoT paradigm, Bluetooth Low Energy falls really far behind in the case of scalability. It is a major disadvantage. Now, power line communication or PLC. So, as the name power line communication suggests, it is mainly concerned with electric grid. It is mainly with grid, smart grids and all. So, it is concerned mainly with home to grid application. Devices can interact directly with the electricity grid via the internet to report the utilized energy. So, you can see that it is more helpful in the case of the electricity billing or how much electricity has been consumed. All those communications related to the smart grid can be handled by power line communication. Smart grid network, road transport communication, and intelligent street lighting form the important applications. So, smart grid and road transport, you might be familiar. Intelligent street lighting means it's like this. Uh, a single sensor should trigger the activation of multiple street lights at a time, and they should be controlled. The different street lights should be controlled. That is an application of PLC. Now, the devices using PLC include all electric devices, smart electric meters, home appliances, electric plugs, and all. Now, the major advantage is that the multicast again is not efficient. You can understand it using a simple scenario of intelligent street lighting. Intelligent street lighting is an application which requires multicast because all the street lights should work simultaneously. Otherwise, it is not good. So, if efficient multicast is not present, then there could be compromises in the applications that are to be satisfied by the PLC. Now, we can see another technology used. It is Zigbee IP. Zigbee IP, that it is actually, I think all might have heard about this technology. It is used in mainly in sensor networks. Most of the sensor networks use Zigbee IP. It offers low cost two-way wireless communication at very low power consumption. It is two-way. You remember that in the case of IoT aware networks, two-way wireless communications are needed because there is traffic to the internet and there is traffic from the internet. So Zigbee, there is no surprise that it has become more popular in the case of wireless sensor networks. Now, devices can operate without a centralized control. Again, another advantage. In all other cases, a central base station is there. But in the case of Zigbee, there is no need for a centralized control. Distributed control is possible in the case of Zigbee IP. We know that centralized control can result in a lot of disadvantages like single point failure and all. But I am not denying that it has advantages. But in the case of dynamic topologies like sensor networks or IoT networks, it is always better to have distributed control. Zigbee IP allows that. So here a device can function as a Zigbee coordinator, Zigbee router, or a Zigbee end device. So Zigbee coordinator means it is the end gateway. So even though it is termed as coordinator, it is not coordinating the routing actions mainly. It has no direct influence on the routing action. The thing is that it is possible for the or it is responsible for the creation of the network. So even though it is there, distributed decisions are possible, then Zigbee routers are there, then the end devices are there, all these kinds of nodes are there. Now, the applications using Zigbee include smart energy, home automation, industrial remote access, and healthcare and retail services. In this, so we can say that Zigbee is used in almost all the sensor network devices, sensor networks, applications where sensor networks are used. This is the most popular one. It is used in sensors, light switches, thermostats, and all. Now, power efficiency is the most critical aspect concerning Zigbee IP. So that is the main thing here. All other things are handy, but why we develop anything on Zigbee The major concern is power efficiency. Anything, any protocol, let it be routing, let it be multicast, let it be addressing or anything, power efficiency should be considered. That is the major scope for improvement in ZigBee. Now we can see 6LoWPAN. As I said, it is expanded as IPv6 over low power wireless personal area network. As we have already seen, it is providing interoperability. So a definition can be said like this: it is a lightweight version of IPv6 protocol. So why a lightweight version of IPv6 protocol was necessary? That is because IPv6 is mainly concerned with traditional internet devices. But in the case of IoT devices, they are very much resource constrained. As a result, most of the protocols and operations concerning with these IoT devices will also be lightweight. So it is actually a lightweight version. It provides the required network layer interoperability. Again, when I say network layer, please do not get confused that with the IoT network layer. What I am saying is it is concerned with the sensing layer. We have seen that low power, low C networks are present in the sensing layer. But low power, low C network is a network of its own, whether it is connected to the internet or not. It is a network of its own. Since it is a network of its own, it has the standard protocol architecture and there is a network layer for the LLM. So we can say this network layer is actually network layer of networks present within the sensing layer. It is not the network layer of IoT. So it provides the interoperability. That is, since there are ZigBee devices, RFID devices, PLC devices, and all, the required network layer interoperability will be provided by 6LoWPAN. The 6LoWPAN performs the header compression required to suit the resource-constrained IoT devices. In this case, 6LoWPAN will do a compression of the header, packet header, and this will be done between the data link layer and the network layer. This will be done so as to get the header compressed, and that will be more suited for the resource-constrained IoT device. Now, through the usage of gateways, 6LoWPAN packets can be converted to standard IPv6 packets. This is essential because 6LoWPAN works only within the LLN area. Once the low power, low C network becomes a part of the internet, or if the data from low power, low C network is going to pass through the internet, then it should be converted. 6LoWPAN should be converted to IPv6. Then only it will work in the traditional internet. So when it is within the, we can say like this, within the sensing layer, 6LoWPAN is enough. But once the packets moves from the sensing layer to the network layer, to the backbone or the global internet network, then it should be converted to the traditional IPv6. That can be done through the usage of gateways. And also, you note one point, 6LoWPAN also facilitates the transformation of each device into a web server. Please note, this is not coming in the scope of this talk. Just saying that once things are becoming part of internet, web plays a crucial role, and 6LoWPAN also facilitates that transformation. But this is not coming under component network. So this is a representation of 6LoWPAN interoperability. You can see this 6LoWPAN adaptation layer. So this is the layer where header compression is performed between the data link layer and the network layer. Between these two, the adaptation layer will perform a compression and it will give the interoperability. That is, different protocol stacks will be there, DEC will be there, PLC will be there, BLE will be there, ZigBee will be there, and all these can be done using 6LoWPAN standard. So till now we have seen what is the structure or topology of LLM, and also we have seen the different networking technologies used in LLM. Now we can see the routing technique in LLM. Routing, that is it is a procedure of transferring data from one node to another through well-established routes. Both proactive as well as reactive routing protocols have been developed for LLM. So first we can see proactive or table-driven. Proactive means the routes are defined or stored or established or created even before. That is, it is stored even before the actual need. So once it is stored, when the need actually comes, it can be used. So an example is routing protocol for LLMs or RPL. So this has been defined as by the IETF as the de facto IoT routing protocol. So it is actually the most common routing protocol used in IoT networks. And that standard has also been, that is the name of de facto IoT routing protocol has been rightly given to it by the researchers. Then there is reactive on-demand routing. In the case of reactive, that means the routing information is not pre-stored. It is created only on demand, like AODE routing, which you may be familiar. So in the case of LLMs, an example is lightweight on-demand ad hoc distance vector routing next generation or load NG. This is another. So when comparing these two, RPL is the most common and I think it is the most useful also. So we will go into detail of RPL and all. So IETF has created a working group named Routing over Low Power and Lossy Networks or ROLL for developing LLM routing protocols. So anyone interested can visit the IETF ROLL website in order to see which all are the hot topics in the area of LLM routing. I think there are still a lot of open problems which are directly listed in their website. So anyone interested can surely visit their website, and that will be a good idea. Now we can see a brief idea of what is RPL. I am only explaining RPL because it is actually the most popular one used. As I said, it is a proactive one. Now it is operating using a destination-oriented directed acyclic graph. It is abbreviated as DODAG. So this is an example. This will be the border route, the green node, and all other nodes will be standard LLM nodes. So this is known as destination-oriented directed acyclic graph. This route, and then there is a parameter called rank. Rank means it indicates the reachability to the node. So in this case, they have used the routing metric of hop count alone. So in the case of 2, only one hop. 3, only one hop. 4, only one hop. Similarly, it can be different, but in the case of 6, it is 2. 1, 1. So similarly, such kind of metric can be designed. So it need not be hop count on always. We need to develop different routing metrics. Then only RPL will be efficient. I am just showing this figure to make you familiar with how a topology looks like. So this is the routing topology. This is how the routing topology in RPL looks like. Research. So we have seen that LLMs refer to a class of resource constrained networks. Be thorough that is LLMs is not a peculiar form of network. It consists of different resource constrained nodes of different standards. All these things, all these component networks of IoT has been defined under the term LLMs or low power lossy networks. It encompasses nodes operating on different networking technologies that again we have seen. LLMs offer a substantial amount of research challenges like addressing, routing, and many more. That we will see in the next section. We can see the open challenges. First is in addressing. In the case of addressing, the first one, flexible allocation of addresses to devices in the network at any time. That is, devices should be able to choose an address for communication in any application scenario. That means address allocation should be automated or self-initiated by the device. Why? Because when things are going to get connected to the internet, there is no particular limit to how much things are going to get connected. Therefore, we can frequently get short of the IP addresses available. So instead of manual configuration, always automated configuration is better, and more research need to be conducted on that side. Then network address duplication detection. This is especially important in the case of devices with multiple interfaces. So in the case of IoT devices, like any devices, they can have multiple interfaces. Suppose a single device has two interfaces and one will be operating in two different departments of the same hospital. Again, in that case, if there is network address duplication, that is if both the interfaces are using the same address, that is not possible. So such kind of duplication detection, that again is a problem in the case of IoT networks. Then self-configuration of network addresses. That I have already said in the first point. Again, for devices located in the remote locations. Remote locations means the locations where there is no easy human access. In that case, is it possible for us to manually configure the IP address for device? It is not possible. Therefore, in that cases, self-configuration of network addresses should be there. For example, you consider the case where underwater sensor network or underground sensor network is a part of IoT. In that case, human access is not always there. Therefore, self-configuration of network addresses is needed. So these are some of the issues in addressing. Now routing. Next, we have seen a brief overview of routing. Now we can see the challenges. LLM routing protocols need to handle both uplink and downlink traffic that we have seen. That is, in the case of IoT network, there is traffic from the internet and to the internet. Therefore, routing protocol should take into account that, and that should be developed. And that I'm sure it is not still developed. There is more possibilities and opportunities in that field. Presence of asymmetric links requires the design of appropriate objective functions. I hope you are familiar with objective functions. Objective function means it is mainly the routing metric. That is how a particular route is selected, or what is the measure for um, the performance of a particular route. That is called objective function. Since asymmetric links are present, we cannot use a single metric like or a simple metric like hop count. If the all the links are similar and equally stable, then it is okay. We can use a simple metric like hop count. But since it is asymmetric and highly unstable, we cannot use such objective functions. We have to design appropriate objective functions and then routing metrics also. That is again another opportunity. With the introduction of industrial IoT, abbreviated as IIoT, mobility is a concern which needs to be addressed by routing protocols. So when Internet of Things was in the nascent stage of evolution, mobility was actually not a part. And in fact, even the de facto routing protocol called RPL was not designed to accommodate mobility. It is a concern only after the later stages of development of IoT, especially with IIoT or industrial IoT. That should be concerned. Again, that is another opportunity. Then context-aware routing offers a lot of opportunities in LLM routing. Context-aware routing means the routing decisions are taken based on the scenario or context. This can result in a lot of energy saving. For example, you consider smart street lighting. In the case of smart street lighting, suppose the street lights can sense the fact that no human being or no one is actually passing through that street at that point. If it is able to do that, then it can automatically suppose reduce the brightness. So such kind of a routing decision is entirely context aware. So if that is done, a lot of energy can be saved. So such kind of context aware routing techniques is a real possibility for researchers in the case of LLM working in LLM. Then efficient multicast protocols need to be developed. Again, in the case of LLM, most of them are preferring multiple unicast. That is not possible. Even though multicast protocols are available, the amount of research on multicast protocols for LLMs is vastly reduced or vastly minimal. Therefore, efficient multicast protocols need to be developed. Again, the next challenge, quality of service. Quality of service refers to how well an application is being performed by the network. That is, an application can be done in different ways. Either it can be done, suppose a bomb detection. The thing is, timeliness should be there. Again, and if it is not detected in the correct time, even though it has done its duty, we cannot say it as good. Therefore, that is the definition of quality of service. It does not matter whether an application is performed, but it should be performed with the required quality. That is what is indicated by the quality of service. LLMs may have to accommodate multiple applications at the same time. This is because LLMs is a part of IoT. We know that IoT is highly application specific. It is not simply about data gathering. It has a lot of societal applications. So LLMs, even though a single LLM, a single physical network is present, that physical network will have to accommodate multiple applications. And each application will have its own quality of service requirement. So what can we say? A single physical network will have to adjust multiple QoS requirements at the same time. This is again another challenge, which is not yet addressed by the researchers sufficiently. So consequently, a single node may have to perform routing decisions based on multiple QoS requirements. Again, this can be done. This can be considered as a highly important research challenge. So this is regarding the different applications of IoT. So here you can see like this, the what to say, this vertical thing. This is regarding an application. This is IT. This is retail. This is transportation. This is industrial. This is healthcare. So vertical aspect corresponds to each or unique applications of IoT, and the horizontal concept. So here this represents an aspect of healthcare. This respects another aspect of the same healthcare domain. So we have to do the quality of service integration or interoperability in both horizontal as well as vertical integration. This is again a challenge. Now another challenge is resource optimization. We have seen that LLM is a resource constrained network as defined by the IETF. So resource optimization is needed for successful IoT deployment. Ineffective and defective devices can waste network resources. That is for sure, because ineffective devices can make a lot of false network decisions. Suppose routing decisions. They can make a lot of incorrect routing device decisions, and this can result in the wastage of the entire network resource. Such devices can lead to network congestion. Again, suppose due to the uh, due to a false decision of a device, if that device gets switched off, what will happen? All those traffic will get shifted to another device. Similarly, the presence of more and more of such devices can lead to network congestion. Optimization protocols should apply cognitive intelligent algorithms and adjust resource allocations accordingly. This again is another area. Here, intelligent algorithms or machine learning algorithms should be applied and optimization should be done regarding the resource utilization of nodes in the LLM. Now, another area, that is information centric networking, which is abbreviated as ICN. ICN or information centric networking matches with the content specific nature of IoT application. We have seen that IoT is concerned with data or applications. It is application specific. So in the case of information centric networking, routing is not done based on IP address. It is actually done based on the identifier of the name of the object. It is done based on the name of object, and in fact that will match a lot with the IoT application. So that is an area. So in-network caching is possible with ICN, since there is no routing decision or there is no need to store the IP address and all. That's several important data can be cached within the network itself. That is possible. Then naming flexibility can improve the scalability. So here we have seen that IP address is not needed. So we can attach any number of devices to the network because we are giving only content identifiers. We are not giving the IP addresses. So even though more and more or infinite number or infinite, not infinite, it is nearly or very large amount of devices are going to get connected to the LLM, naming flexibility is a real advantage of ICM. Then improve security by securing the content itself instead of the communication channel. So here, since routes are not constructed, there is no need for securing the communication channel. Instead, directly the content can be secured. Then receiver-driven nature of ICN supports mobility to a large extent. In the normal networking condition, it is sender-driven. That the sender node initiates the routing procedure, but it is not in the case of ICN. It is receiver-driven. In this case, receiver wants something and it initiates the routing decision. So since mobility or mobile devices are usually at the receiver end, ICN can be an important tool in order to accommodate mobility in low power and lossy networks. Now finally, this is an aspect which is to be concerned with anything. with any protocol in any area, that is security. Even in the case of IoT, in fact, a lot of our personal information is involved. That is, a lot of information, personal information is gathered. Therefore, security is actually is of utmost concern. It is natural. Security should be there. Most IoT devices have limitations in processing power and battery that we have seen. And what about the cryptographic algorithms? All the cryptographic algorithms are usually computationally intensive. So we have to make it lightweight. Then only it can be applied to the LLMs or the component networks. So be it routing, multicasting, or anywhere security is applied, lightweight security protocols need to be developed. Then only it can be successfully applied in the low power and lossy networks. So this again is somewhat kind of a conclusion. Internet of everything. Internet of everything. And IoE and IoT is actually same. IoE just represent IoT in a broader view. That is, IoT is not just Internet of things alone. Things are also present. That is the definition. Things are also present in the Internet along with the traditional Internet devices. So that is why sometimes IoE is used in place of IoT in a broader view. So we can see if you are saying as IoT, then the component network is LLM. As I have said, LLM contains all. It could be vehicles, it could be sensor networks, it could be RFID or a combination or anything. So if you are using the term IoT or Internet of Things, then the component network is low power and lossy network. If you are using the term Internet of Vehicles, again understand IOV is nothing but a part of IoT itself. So if you are using Internet of Vehicles, then the component network is smart vehicle network. Again, if you are using the term Internet of Drones, then the component network will be flying ad hoc network. So what we can understand, either IoD or IoV or anything, it is actually IoT itself. IoT represents these two or any other thing in more general manner. And LLM represents smart vehicles, flying ad hoc network, or anything which is a part of IoT. So this is the most generic representation, IoT and the component network LLM. We can conclude. We have seen Internet of Things is the result of the constructive fusion of technologies like embedded systems, networking, cloud computing, and data analytics that we have seen. Component networks, they form the backbone of the entire paradigm. We have seen component networks are present in the sensing layer. Sensing layer is the bottommost layer and hence it is the backbone. That we have seen. Low power and lossy networks, abbreviated as LLM, collectively refer to the different component networks. Again, we have seen low power and lossy networks does not refer to a single standard. It could be anything. The thing is that they are resource constrained, and it refers to a collective or a collection of different networks in the IoT. LLMs offer a wide range of research opportunities that we have seen. That include addressing is there, routing is there, security is there, resource optimization is there, quality of service is there. A lot of research opportunities are provided by the LLMs for researchers. So for experimenting with protocols in component networks, there are two methods. We will give a very brief outline. Either you can use simulators or you can use actual devices. But I think simulator is more preferred now because um, then only more aspects like scalability can be taken into consideration. If you are using real nodes, sometimes there might be limitations on the number of devices and all. So these are devices, and I think these are provided for academic institutions by institutions including CDAC. Either you can do that or you can use simulators. And out of simulators, Contiki Kuja is the most common one because it provides a virtual operating system called Contiki. And that Contiki operating system is the operating system corresponding to the IoT devices. So that is the most common one. Anyone interested can primarily do their experiments in Kuja. All these RPL protocols, multicast protocols, all these things are inherently supported by it. Then NetSim is there. There are different NetSim. TechCos NetSim is good. In fact, that is highly advanced simulator and it is not available freely online. And but if you can obtain it, it can result in a lot of saving of your coding time. It is that much advanced. But Kontiki Goja is available freely. So these are some of the major conferences and journals in this field. Conference one is there is an ACM conference of IoT. That's a general conference. Then there is COMTech. It's actually conducted in India by the IIT and IIT. It's actually concerned with application. So if you want papers on networking aspects of IoT, this is the reference. And journal again IoT journal is there. It is again a general journal, covering all the topics of IoT. And if you want the networking aspect of IoT, ad hoc networks journal of Exiver provides a lot of good papers on that area. So these are some of the links. If you are interested, you can visit. One is IETF role. This is the working group which I have mentioned. It consists of all the open problems and their suggestions regarding routing in low power lossy networks. It is a really useful site to visit. Then again, there is another working group called IP Wave. This is not as detailed as role in the case of IoT. It is actually concerned with vehicular alone. So it is also useful, but for the purpose of research in LLM, this is preferred. IETF role is more preferred. These are the references. So any questions, please ask. Thank you.
Thank you, Mr. Jayaswara. Thank you, Madhu sir. I am interested to know one thing about the routers that we use nowadays. As per my earlier experience, routers are very sensitive to lightning surges. So, is there any scope of adding protection against lightning surge in a router?
Again, and if you are talking from the field of architecture or embedded system, that is
Pardon, Jayaswara, you are not that audible. Can you please be louder?
Am I audible, ma'am? Am I audible?
Right now, you are audible.
Okay, ma'am.
Yes, yes, what are you saying?
Oh, if your question is regarding the embedded system, so regarding how you can make the design of routers, that is actually not my. I have not
Okay.
done. I have not done. It is regarding the routing. That is, if you are going to use the existing routers, which is and make it more suitable for those kinds of environments, there is definitely scope for the development of more routing, more efficient routing protocols that can be adaptable to such situations, like that underwater sensor networks are there, then underground sensor networks are there. So if you are concerned with routing algorithms or routing protocols, there is definitely a scope for improvement.
Okay. Well, perhaps actually I couldn't understand all the words. Perhaps I will listen to it later on because the voice was breaking. But anyway, uh, thank you, sir, and thank you, Mr. Jasuraj. On behalf of Electrical Engineering Department, we'll be presenting you the certificate of appreciation so that it's visible to all the participants as well. Is Can you please stop your presentation, Mr. Suraj? Just
Okay.
is Professor Madhu here as well?
Yes, ma'am. I'm here.
Okay. So this is the token of appreciation for you, sir. I will send the same to you if it's visible.
Yeah. Yes, it is coming. Yeah,
Okay.
thank you, ma'am.
Okay. Thank you, sir. Now I will show the one for Jay Suraj as well. This is for Mr. Jaisuraj.
Thank you.
Okay. So thank you for being with us for the second time. And
Yeah.
hope that if you arrange in any other program in future, we will seek your cooperation once again. And thank you for sharing your knowledge and time with us. So goodbye.
Yeah. Yeah. You are welcome, ma'am. Ma'am, if you have the YouTube links of, if you have recorded these lectures,
Yes, these
can you
lectures have
share
been
the YouTube?
recorded. Yes, sir, these
Yeah.
lectures have been recorded, and all the recordings will be put in the YouTube, and we will share the links of YouTube to you and to all the participants as well. Once the
All right.
program
Thank
has
you.
completed. Okay, sir?
Okay,
Okay.
thank you.
Okay, ma'am. Thank you. Thank you.
Thank you, sir. Thank you, Mr. Jasuraj.
Thank you, ma'am.
So now we will switch over to the next session, and our distinguished speaker, Professor Paramita Chattopadhyay, has joined. So I would request Rupa Madam, are you there? You please introduce the speaker.
Yes, ma'am. Welcome everyone present here. Now we are entering towards our next session of today. Today we have Professor Paramita Chattopadhyay as our honorable guest for this session, and she is already with us. It will be my privilege to introduce our honorable speaker. Professor Paramita Chattopadhyay received the BE, ME, and PhD in Electrical Engineering from Bengal Engineering College and Science University, Shibpur in 1993, 1996, and 2002, respectively. Currently, she is an associate professor in the Department of Electrical Engineering, Indian Institute of Engineering, Science and Technology, Shibpur. She received Young Scientist Award and Commonwealth Fellowship in the year 2002 and 2003, respectively. She was a visiting professor in Hanyang University, South Korea in the year 2008. She has executed number of sponsored research projects funded by DST, AICTE, CSIR, IE, and NPP projects of CPRI, and developed laboratory with state-of-the-art facilities in the area of condition monitoring and rotating machines. She has published more than 50 research papers in various international journals and prestigious conferences and filed 2 Indian patents. She has already guided 3 PhD and 25 MTech theses. 4 more PhD scholars are working under her supervision. Dr. Chattopadhyay is an IEEE member. She has already taught the courses like electrical and electronic measurement, signal and systems, soft computing, AI and ANN in undergraduate level, and condition monitoring of electrical equipment. Application of soft computing in electrical engineering in postgraduate level. She is a passionate researcher, and her research interests include condition monitoring of electrical equipment, machine learning, signal processing, design and development of intelligent systems, AI-based smart grid management, energy informatics, learning in control and applications of nanotechnology in power and energy sectors. So welcome, ma'am. In our STTP phase 3, the session is all yours.
Yes, thank you very much for your kind introduction and good morning to all of you. So let me present my slides. So I think I am audible.
Yes, ma'am.
So I would request all of you to keep yourself muted so that we can listen properly. Yes. Yes. So let me start. Very good morning to all of you. So the title of my presentation or the talk is sensing, control, monitoring in smart grid environments. So before going to the talk, let me tell you what is the layout of my presentation. It will be started with the introduction, then the deployment of smart sensors and energy efficiency, followed by worms-based intelligent monitoring and control, big data analysis in smart grid environment, artificial intelligence-based tools and techniques which are used for big data analysis in smart grid environment, deep learning-based grid event classification, implementation of 1D convolutional neural network in embedded platform, where I would present one video prepared by my research scholar in our laboratory, how we have implement the deep learning in a generic form in a Raspberry Pi platform and can be used for the various applications and the challenges and future scope. So we all know that the energy is the most important thing for any kind of development. Still today, the major share of energy are of fossil fuel. However, in year 2015, which is a very pivotal year in the energy map, where all the climate scientists, they took an oath that rampant use of fossil fuel for generation of power has made causes like global warming and the climatic changes, and so we need to go for sustainable energy sources where we would be able to reduce the carbon footprint. So the main agenda in that Paris Accord was that the effective management of load, reduction of losses and waste management, and of course the use of large amount of renewable generation to reduce the carbon footprint for sustainable development, overall sustainable development. So these three are the main outcomes of this Paris Climate Change Agreement in 2015. We all aware of that the reduced carbon footprint, increased renewable energy and energy efficiency. So these three are the key components. So have a look on the overall CO2 emission in the various global carbon dioxide emissions in the various sectors. Definitely the major share is by the industry, then the building and the transportation. So how can we reduce this carbon footprint? Here I have shown the low carbon hierarchy. So there are basically three means by which we can reduce this carbon footprint. One is, first of all, is we can reduce our demand. If the demand be reduced, then definitely the fossil fuel generation which we are used, it can be controlled, that we can reduce the carbon footprint. Another thing is that if we make our appliances energy efficient, or the system is totally energy efficient. Another is that instead of using a fossil fuel, if we integrate the renewable energy. But decarbonization is not cost effective in all the situation. It is expensive. So here I am trying to show the hierarchy, low carbon hierarchy with respect to its cost. Most cost effective is the reduced demand, then the energy efficiency, and then the renewable. So renewable energy integration, which is the call of the day, it's keep in mind that still today the renewable integration is not cost effective. So however, if we look into the energy map of the India, we would find that the last 3 to 5 years, there is a huge penetration of renewable energy. You see, in the last 2018, the total penetration of the renewable energy is the 74% of the total energy enhanced. So this huge penetration of renewable energy sources has imposed challenges towards the planning, operation, and control of the power system. So what are the various technological challenges that we would discuss due to this integration of the renewable energy? And to combat these challenges, we technocrats we power engineers, what we can do, that also be some of the parts would be addressed in my lecture. So this is the to combat with these technological challenges, we need to move towards a smarter grid where both the economics and the environmental uses for this transition from this current outdated power grid to sensor-embedded smart grid that monitor the system stability, integrity, and the schedules energy consumption of the household users. So it's going towards a smart grid was the urge from the both economical and the environmental. So for agenda, we can say to improve the environment, enhance the value for energy, improve the energy efficiency, and also to improve the quality of life. So have a look what is the changes in the smart grid in our energy system or the power grid. So these are the scenario in the past, these are the present, and this one would be the in the future. The major changes what you have observed that this communication, both way communication, in the last lecture which I have listened that he was discussing, Jai Shivjo was discussing about the wireless networking and the IoTs and this. Yes, this ICT, information and communication technology, has been are now extensively used in the power network. So the conventional network, conventional power grid, it was absent. In the present grid system, we are integrating renewable energies. We are using the information and the communication technology. That means we are we are using lots of smart sensors. So what are those sensors I will discuss. And these sensors has been used to combat the upcoming challenges due to the integration of renewable energy and to meet up the decarbonization agenda. So in future, what would happen? More renewable integration, more challenges, and we would use more storage and more IoT applications would come up. So the new players in smart grid ecosystems are two-way flow of energy and information, renewable energy, distributed generation, which was conventionally the concentrated generation, use of power electronic converters because as we are using the renewable energy, we have to use our system grid is in AC, so we have to use the various converters, power electronics converter, to convert this DC energy to the AC one. As a result of this use of this power electronics converter, we have we are injecting lots of harmonics, and the various power quality issues are arising. To combat all these challenges, we are using various smart sensors, and we are using various data analytics techniques for intelligent grid control. At the same time, to decarbonization issues because our conventional vehicles, they contribute a large share of carbon dioxide. So we are proposing the use of electric vehicles, and they are another important challenging items for the smart grid. And lastly, the storage. Then the storage is also playing a vital role in smart grid environment. So I would try to touch upon some of the issues. Particularly, I would mainly concentrate on how we can use the intelligent grid control by data analytics or the machine learning or artificial intelligence based techniques, and that would be the major thrust of my lecture. And in this context, I would use the wide area measurement techniques. So this is the smart grid ecosystem. It would start definitely first we have to make our home smarter, that means energy efficient, then the building, then the smart city, and finally the entire environment would be the smart grid. So the energy efficiency is the key to reduce the global greenhouse emissions. So to achieve this, we have deployed various smart sensors and we try to make our system energy efficient. I am trying to give some of the examples, though it is not the major motive of my lecture, objective of my lecture, but in the context of big data analysis, I would like to mention how we are getting the huge amount of data. For example, in a smart home, we are talking about, we are uses various appliances at our home, starting from the air conditioner to the refrigerator. So we have the home area network. We can have the home area network and intelligent home devices, that all the appliances which we are using would be maybe embedded, though it is not quite popularly used in the Indian scenario, but in abroad, in many situations now, all the appliances are embedded with intelligent sensors, which you are called the IoTs. The sensors are sensing. For example, it may be a carbon dioxide sensor, it may be a sensor of the light illumination level. In this way, this kind of sensors it is using, and based on this information gathered from the sensors, it is taking decision how to optimize the power consumption in a home. It may start from a particular room to at home, then home to at various buildings. It may be the administrative building, it may be in the academic buildings. In the academic building, definitely in the classroom we can apply this kind of system. In automatically in the office we can use the optimization of the energy. This can be easily done by adding some smart sensor. Another important is the smart meter. Instead of the conventional energy meters, in many situations the smart meters are used. The smart meters, they are basically both-way communications. They have the both-way communication between the utility and the consumers. So main advantage is that with the help of these, the utility can also get an information, the pattern of power consumption of the users or the consumers, and also consumer can be updated with the power consumption by it, the rate of and also the total bill of the electricity and the present rate of the electricity, and accordingly it can plan its consumption of power. So it's a very transparent system, and the data received every 15 minutes we get the power consumed by the each consumer through the smart energy meter system, and through clouds it can be stored in the server, and this data, historic data, past data, can be utilized to predict the future load forecasting, for short-term load forecasting, which is very important in power, in grid management. That is what is our prediction of load and what is our available generation. And according to this, in smart grid environment, there will be dynamic pricing of the energy. So I would come up. So one thing is the smart metering. So this is the smart metering system. Another is that each building, we called it as building to grid and the grid to building, or the vehicle to grid and the grid to vehicle, or this informations. And these are also the renewable energy which is generated at the house. Either it can be used by the household itself, or the excess energy can be transmitted to the grid. And when I would consume the energy, and when the energy would be supplied to the grid, that can be decided with the help of some sensors. Smart solar sensors we can use. So these are the typical example. This is also for the grid to vehicle and the vehicle to grid we can use, because the electric vehicles, they have also the lithium-ion battery where we can store the power. This power can also be utilized when there is a deficiency of power in the grid, and when there is excess power, the power can be stored in that battery. So we call it as the vehicle to grid and the grid to vehicle. So all are embedded, all are assisted with some smart sensors, and these sensors can communicate and gather lots of data. So in the, as I mentioned, in the smart grid environment, depending upon the energy consumption and the generation, we have the dynamic energy market. So it would be, energy price would vary depending upon the generation and the demand. So we can, and price of the energy would be determined, but the availability and the demand. And in that situation, the information gathered from the various smart sensors embedded in the various components of the smart grid ecosystem would play an important role. So in next part of my lecture, I would try to explain how we can get the information from those sensors. So due to this lot of information gathered from the various smart sensors in the smart grid environment, it has given a birth of a new subject which is known as the energy informatics. What is energy informatics? Energy informatics, which exploit the state-of-the-art information and communication technology, which uses the computational intelligence techniques or the data analytics techniques to find out to extract the hidden information from the data, huge data, to tackle the global warming and the climatic changes, and to make the efficient integration of renewable sources of energy by making our power system smarter. So basically the energy informatics is try to overlap, try to combine both the energy, AI, and information. These three domains are clubbed together, integrated together: energy, information, and AI. Definitely, here the economics is also playing an important role. That the energy trading we are talking about. So this is one part. Now I am coming to the another part of my lecture, that is wide area measurement system based intelligent monitoring and control. So what is why there is a need for wide area measurement? So before that, as I mentioned earlier, there are three ways we can reduce the carbon footprint. One is either we can reduce our demand, that means demand side management. Either we can, second is we can make our system efficient. Another latest one is the renewable energy integration. So it is not possible that in any growing developmental process to reduce the demand all the time. Definitely we have to optimize its use, we have to make the system efficient, but with the development, the demand of energy would increase and we have to meet up by the generation. And as we have the mandate to reduction of the carbon footprint, we have, instead of using conventional fossil fuel, we are going for the various novel renewable energy sources, particularly the solar and the winds. But what are the major challenges that the renewable energy integration is imposing, particularly from the point of grid stability? As you know that as the renewable energy, which are DC in nature, so we are using the power electronic converters to connect it to our conventional grid, conventional AC grid, and the loads which are also AC in nature. So this, when we are connecting this renewable sources to our AC grid, there is an issue like voltage and frequency instability issue. The more the renewable energy means less the grid stability. Question is why? Because we know if you look into the frequency instability, that means here I have tried to show that this is a generation and this is a demand. When there is a mismatch between the demand and the balance, then what would happen? Our AC grid, the frequency at which it was operating, it would change. There would be change in the frequency, which is mainly change in the frequency, which is mainly governed by the inertia of the system. So if the generation is more, the frequency goes up. If the demand is more, the frequency goes down. So, however, how much? What would be the change in the frequency? That means rate of change of frequency. It would become more sensitive when the, definitely this is analogy I am trying to draw, when the inertia of the system is more. If the inertia of the system is high, then even if with a large gap of generation and demand, there would be not very deviation of the frequency. So with the basic fundamental equations of the power system, we know that this gap delta P, that the gap between the generation and demand, can be written in this form, where H is the inertia of the system. This inertia of the system, and d omega by dt is the rotating speed. So it would come as d omega by dt, that means which is coming d into twice pi into f by dt, which, so we can say that the df by dt is proportional to the delta pi by 2 into h into system. So what is the inertia? When, if we think about only the fossil fuel based system, that means steam turbine and all, its inertia order is in the order of um, 8 or 9. On the contrary, if the solar system, which are static in nature, particularly, their inertia is in the order of it's below 1. So when we are adding huge amount of renewable energy in the system, it creates a lots of problem, lots of issues. The system is becoming very sensitive to this rate of change of frequencies. And then what is happening? We have the rate of change of frequency relay. If the system is very, very sensitive to the rate of, sensitive to the rate of change of frequencies, then what would happen? Even if with the small disturbances, this df by dt would be so high that the relay would trip. And once the relay would trip, that means our energy sources would be disconnected from the system. And as the energy sources would be disconnected from the system, that would mean again more mismatch, more delta P. That means we should create more df by dt instability in the system, and in this way the cascaded failure would occur. And it has been reported that in the power system in the recent past, most of the blackouts are mainly due to this df by dt operational sensitivity, and mainly due to this kind of cascaded failure. So major issues is that we are talking about integration of renewable, but how much amount of renewable energy we can integrate in our grid, it is a great challenge. Even if, as per my knowledge, according to the literature, more than 30 in Europe and all, around 37% renewable energy they have still integrated over the overcapacity, though they have a plan to integrate around 70 in some cases. The 100% renewable, it's fine, but this renewable integration means we are reducing our inertia, which is imposing great challenges to the stability issues. So how to combat with the stability issues? Is our conventional power system protection schemes are enough to take care of this? Definitely not, because conventionally we use the distance protections of the transmission line. But this distance protection, what is the basic concept of the distance protection? Is that the distance protection, it works or it measures the impedance from the location of the relay to the fault position condition. But in power system, in the smart grid environment, we have the renewable energy sources, so we have the bidirectional power flow due to distributed generation, and also we have the fax devices. So actually when we are measuring the impedance, that impedance value is not giving us a true picture. So it is not possible truly to use and distance relay to predict these kind of disturbances which is occurring and take the correct decision. So apart from the conventional distance protection, we have to use the and other protection technique, from where the wide area measurement would are playing a very important role. So what is wide area measurement techniques? Wide area measurement system. It is a new idea in the system protection of electrical networks spread over a wide geographical area. Right? So instead of taking, in case of distance protection, what we do, it is a local protection. So for a transmission line, particular transmission line, we are using the distance relay. But the concept of wide area monitoring is over the vast geographical area. We are placing some sensors. What is that sensors? So these sensors in wide area measurement system, the heart of the wide area measurement system is synchrophasor measurement, which is known as the phasor measurement units, which provides, what is the phasor measurement unit? So these are, I'm trying to show, these are the phasor measurement units. They are distributed among the vast geographical areas. So what is phasor measurement unit? It is a device, rather you can say the sensors, which provides the voltage and current phasor information synchronized with high precision to a common time reference provided by the global positioning system. So what is that? In case of phasor measurement unit, the major thing is that we are measuring the phasor. Phasor means the magnitude as well as the phase angle. But when we are measuring, we are talking about the phase angle between the two bus or the two systems. Definitely phase angle we must have to measure with the reference frame we need. If I say that a phasor V1 is at a phase angle of 30 degree and a phasor V2 at an angle of minus 35 degree, definitely this 30 degree and 35 degree we have to measure it with a common reference frame. Thanks to GPS, the global positioning system, these GPS is capable of time synchronize all the measurement of the PMUs in the same time tag. So it is possible to find out what is the phase angle difference between the voltage and the current. Apart from the phase angle, it measures also the frequency and the rate of change of frequency. Because in the power system, voltage stability and voltage and the frequency stability, the phase angle and the rate of change of rate of change of frequency plays a very important role. So the Ohm's wide area measurement system is capable of monitoring the stability of the grid online. How I would discuss. So before Ohm's, we have the traditional SCADA system, supervisory control and data acquisition system. But why we are talking about, why we are proposing going for the Ohm's is that in case of SCADA system, it was sample with a rate of 2 to 4 seconds. We take one sample with a time gap of 2 to 4 seconds. But whereas in PMU-based system, we are taking the samples of this voltage, that means phasors, frequency or the rate of change of frequency with 10 to 60 samples per second. So try to imagine how the sampling frequencies are improved. So in the context of observability, the SCADA system was capable for the steady state, whereas the worm system is capable for the dynamic and the transient stability. Because this dynamic and transient stability is very, very important, unless and otherwise we can sample the system at a very high rate, and which is we can do it with the help of this PMU based system. Here the measured quantity was only the magnitude of the voltage. Here it is the magnitude plus the phase. Phase is possible only due to the GPS. Now the time synchronization was not there. That's why we didn't able to measure the phase. Here the time synchronization is there. That's why we are able to measure the phase. This monitoring was local, as I mentioned earlier. The local area we can monitor, but here we can see the entire power system. If I go into the top of a very high-rising building, we can see the entire city. Here, just like this, at the top, we are monitoring the entire condition of the power system, status of the power system. We try to visualize. This is the basic concept of the worms. So, it is the monitoring is the global. So, this is the inside of the phasor measurement unit. Actually, it is a microcontroller or the microprocessor based system. So the analog pulses, that is the voltage and the current which we are getting, they are sampled at a predetermined sampling frequency. And after that, it is passing through the anti-aliasing filter. You all are aware of this anti-aliasing filter. This anti-aliasing filter is used to eliminate the noise of the system. So this anti-aliasing effect, anti-aliasing filters are used, and after that they are fed to the analog to digital converter to convert their values to the digital values. And this analog to digital converter, this system is phase locked with GPS receiver, phase locked with the GPS oscillator with the GPS receiver. And finally, this value are phasors and measured with the help of a microprocessor. Now, here I have tried to show that how the samples are taken. Suppose this is a sinusoidal waveform and this a predetermined value, the samples are taken. This is suppose voltage signal, and recurring DFT algorithm, discrete Fourier transform algorithm, is used to measure the phasor, because recurring DFT algorithms are very, very cost effective, computation effective. Less computation cost is there. So in this way, we can measure the magnitude of the voltage. I'm not going into the detail of the DFT algorithm, which is used for measurement of this phasors, that is magnitude and the phase angle, because it would itself take a 1 hour lecture. So finally, what we are measured through this sampled voltage and current data is that we measured the phase angle, frequency, rate of change of frequency, because this phase angle and the rate of change of frequencies are the two important parameters to monitor the health of the status of the power system, particularly in the challenging scenario with a large integration of renewable energies. So basically what we are getting from the PMU. So the PMU data packet, the PMU, so we have the sinusoidal signals which is fed to this PMU, and which is synchrophasor data packet because it is synchronized with the GPS satellite. So it creates finally, when it is coming from the modem to the modem, it's nothing but some data packet. So information. What is data? What data we are getting? Basically, this is the magnitude, this is the phase, and this is the nominal frequency, and this is abnominal frequency, and this is df by dt. And this is the time tag, as I mentioned, it is time synchronized. So this data, so now in the power system, in the various geographical locations, these informations are there. These informations are, PMUs are there. They are transmitted to the phasor data, to the server in the phasor data concentrator. So this is the data packet for the phasor 1, phasor 2. In this way, how many PMUs we have. So it has some standardized format to which the data are sent to the phasor data concentrator. And here in PMU data communication, we use IEC 61850 communication protocol. And IEEE, this standard, this standard C37.118 2014, this standard is used for transmitting the PMU data. So now this is the pictorial representation of how we are capturing the PMU data. So we have lots of renewable energies, and we are placed in the optimally, the PMUs are placed in the various locations of the power system, and the data are captured, the time synchronized data are captured, and they are stored in the phasor data concentrator. So huge amount of data is coming because, as I have already mentioned, we have taken 10 to 60 samples per second. So you try to imagine in 1 hour, what would be the amount of data which is coming from the various locations of the power system. Here I would like to mention one more thing. We don't need to place the PMU at all the places of the power system or transmission or the distribution system. We can place them in the optimum locations. We would place the PMUs in such locations from where the observability is maximum. So however, now we are getting this data coming from the various PMUs located in the optimum locations of the suitable locations of the power systems, and they are generating a huge amount of phasor informations of the various buses. Now question is that what to do with this data? Why we are collecting in this data? Because the PMU itself is a very expensive device till now, though its price is decreasing. So I am showing you some snapshots of PMU data. Here you see these are the phase angles. How over the time the phase angles are varies for the various PMUs. They are placed at the various locations of the power system, and you see this is the variation in a particular bus, which is indicating something disturbances has occurred. And here you see the variation of the frequency. It is with respect to the 60 Hz. So how the frequency is varying from its nominal value. It is nominal value is 60 Hz with respect to the 60 Hz because this data is taken from one system of USA. That's why it is mentioning it is with respect to the 60 Hz. So these are just the snapshots. How much I would just like to show you what is the volume of data that is coming to the phasor data concentrator. My objective is that. I think it's clear to you. So I am trying to show you once again the typical power PMU data which is captured for a typical power system events. Here you see due to a fault, line to ground fault, and the PMU data normally it is looks like this, and the red one is for the PMU 9. It is showing some nature, and if the fault is disturbances is other, it may be generated tripping, it may be the other oscillations or perturbation in the power systems, it may be a load throwing, it may be an integration of generation of renewable, various disturbances that may occur in the power system. So as there would be a various disturbances, various kinds of disturbances, the nature of perturbations, the nature of this pattern of this PMU data would vary from one disturbances to another disturbances. Here I am showing you a real data which is occurred in the from Indian scenario in the 1st June in the Rihant. df by dt, there is a fault, and during this fault, you see what is the nature of the df by dt. What is the variation of the df by dt, which is shown by the blue line. So this kind of oscillation which is occurring, the oscillations in the phase angle, that is the pattern of the phase angle or the pattern of the df by dt, this is completely depend upon what is the type of disturbances that is going inside the power system and their severity level also. So can we, from the data scientist angle, can we think these power system events are nothing but some pattern recognition problem? Yes, definitely we can. So the next stage of my lecture, I would try to emphasize how we can use the various machine learning techniques or pattern recognition techniques to classify these kinds of grid events from this PMU data or the voltage data, that's all. So if I just sum up, the various sources of energy data in the smart grid environment, as I mentioned, already mentioned, that is one is the PMU, huge amount of data is coming. Another is the smart meter. Another is intelligent electronic device. It is also a digital protection scheme. Smart solar inverters. This is for building to grid device. This is weather forecasting data. It is used for solar forecasting. As we are, with the help of smart meter data, we are forecasting the load forecasting. Similarly, for the weather data, we can forecast the energy generation. So these are all camera and sensors embedded in the various wind power or the vehicle, just few are mentioned. So this smart gate sensor, they are gathering massive amount of data. We call it as the big data, and it has the 4 important features which is denoted by 4 V's: the velocity, volume, variety, and veracity. So we have basically 4 kinds of data we are getting: smart meter data, grid equipment data, off-grid data, and the asset management data. Smart meter data, as you know, I already have mentioned. The grid equipment data is basically the PMU data. So it's one of the example of off-grid data. Example is the weather forecasting data, and the asset management data is for the camera and all. So you just try to data rate, velocity rate, smart meter we take 5 to 15 minutes or sample. Phasor measurement unit we take to 40 samples per second, 10 to, it varies, 10 to 60 samples per second. And the intelligent condition monitoring, 250 samples per second. Digital fault recorder, it is 1600 sample per second. So huge volume of data and from the various sources. So various sources we are getting the huge volume of data. So what to do with this data? This data has no meaning unless and otherwise we can interpret this data. So this collecting the data alone is useless unless the informations are extracted from this big data set. So in this context, the machine learning or the artificial intelligence based approach may be very useful, because why we are going for the data driven approach? Because in this situation, the conventional statistical approaches are not suitable, or the mathematical modeling based approach is not suitable, because the huge data we are getting from the various sources, various sensors that are coming, we do not know the correlations among those data. But we have to extract the useful information from those. How to do this? In this context, the artificial intelligence or the machine learning based technique may be very, very useful. So in the last portion of my lecture, I would demonstrate how we can use the AI based tool and techniques to extract useful information from these huge amount of data coming from the various sensor networks embedded over the vast geographical area of the power system, to extract useful information or the knowledge to make our system more stable, reliable, and smarter. So why we are going for the AI-based tools and techniques? Because the system is very complex and large in size. Physical modeling is not possible. Classical computation tools cannot handle the adaptability and the stochasticity of the big data of this energy management system, and which demands the computational intelligence. So we go for the artificial intelligence and machine learning based technique. So I do not know whether you have the basic background of the AI or machine learning. So I just use 1 to 2 slides to understanding the basics of AI and machine learning. So before going into the AI and machine learning based techniques, I would like to give you just an idea that in our we human being, AI is just to mimic the human intelligence into the computer. So why we prefer the human intelligence? Because in many situations we human beings perform much better than the computers. But the question is why? The question is why is that our human brain, we have the trillions of nerve cells and which are interconnected with each other, and they work parallelly, and we store all the information. Whatever we do with our human brain, we don't have when we talk about the human memory or the brain, we do not store anything in the form of some digit. We store, even if when we store the phone numbers, we store it in the form of some images in a human brain, and basically some mapping in the various synaptic connections. So that is the major beauty of the human brain, that human brain recognize all these things in terms of the pattern recognition. That's why even if in the uncertain situation, even if we are very adaptive, and when there is a partial truth, or when some informations are missing, we can recognize many things. which a sequential computer cannot do. And that was the main motive for the artificial intelligence or neural network based or the machine learning based techniques. And it has become day by day successful, used for various successful, and now it is the call of the day in the all areas. We are using the AI and the machine learning, particularly thanks to the deep learning approach, which has made real success of AI and machine learning in some complex real-time problem. So let me explain why, what is the key behind this deep learning and how we can use this deep learning based approach in our power system scenario to extract useful information from this big data which we are acquired through the various sensor network. So here I am trying to explain. You see, this is I have just pictorially I have represented some raw data I have shown. So two kinds of approaches there. One approach is called the feature engineering approach, and another approach is called the feature learning based approach. Feature engineering based approach is like that. If I ask you, what is the difference between the green apple and the red apple, definitely you would say the color. So if we have the two classes, the green apple and the red apple, you just say it's by color we can identify it. But you have to know what is the difference. Physically, you have to know about the system. Suppose you have a student database. You are asked, find out the tallest boy or the tallest girl in the class. So what information do you need? In the database, his name, his address, father's name, parents' name, marks, all are given. Are these informations are useful? No. Only we need to know that what is the height. So in that case, to find out the tallest boy, you need to know which features are important. So this approach is called the feature engineering based approach. Another approach is that which is called the feature learning based approach. In that situation, we do not give any features. For example, if I ask you differentiate between the triangular wave and the sine wave. So, in what way? If I ask a feature which would differentiate between the sine wave and the triangular wave, can you say? So, if you know the form factor is the important feature, because the form factor of the sine wave is 1.11 and the triangular wave is little different. So the form factor is the important feature which can identify each kind of waveform. But a person who does not acquainted with the terms form factor, he or she can also differentiate between the various patterns of the waveform. Question is how. Thing is that within our brain we use this pattern recognition technique. This techniques is called the feature learning techniques and which is utilized in the deep learning. So I would try to explain what is the deep learning and how it extracts features and how we can use these techniques in our power system problems. So big data analysis, there are definitely, as I mentioned, the feature learning based, feature engineering techniques, which we normally call the shallow learning techniques, and the deep learning techniques, which we call the feature learning techniques. both lots of applications are there. Depending upon the complexity of the problem, we have to apply judicially, where we can with some of the applications, if the problem is not so complex, we can apply the conventional shallow learning technique, and if the problem is very complex, we must have to go for the deep learning approach. The major difference of the shallow learning and the deep learning is that in case of shallow learning, the features are handcrafted. In case of deep learning, features are self-synthesized. Here the number of layers are normally less than 3. Here the number of layers is more than 3. Here the training data is less, and here the training data is huge. Training time is low, here the less. Definitely the computation cost is less because all are low and less. Here all are high. But another advantage of the deep learning model is that in spite of they have the large training, high training time and the computation cost, is that the learning capability, the shallow learning model cannot extract all the information from the huge data set. I am showing with the graph, I am showing that this is with the amount of data, this is the nature of learning for most of the shallow learning algorithm, whereas the deep learning, they go on increasing the learning. They have a huge learning capability. So let's see how. So the deep learning, it is an end-to-end machine learning technique that learns feature and task directly from the data. That is very important. That means when I ask you to describe an apple, you doesn't need to describe with the shape, color, and skin type and all. Automatically in our brain, we don't store an apple, image of an apple with the separately as a color or the features. As an image, we store it. So a similar approach could be used in the deep learning case. So it would be really nice. It is really nice thing if we learn the features automatically. So deep learning, it is a branch of machine learning. There are lots of deep learning structures are there: autoencoder, restricted Boltzmann machine, convolutional neural networks, and recurring neural networks. But in today's lecture, I would mainly concentrate on the convolutional neural network and its applications in the power system domain. Hello, Navneeta.
Thank you, ma'am, for this valuable and resourceful session. We are blessed to be a part of this session. I'm requesting participants to unmute yourself and please ask questions to ma'am.
Hello, Rupa madam. Madam has not completed, I think.
Oh,
actually, the call went by mistake. I'm extremely sorry for the inconvenience caused. The call
okay,
went
ma'am, I'm sorry.
by mistake.
Oh, okay. No problem. No problem.
I'm really sorry for the convenience caused.
No.
Okay.
It's okay. So I'm continuing. Okay.
Ma'am, I'm sorry also.
No. Yeah. It's no problem.
I can't understand.
No issue. It may happen. So this is the convolutional neural network I would try to discuss. So the first deep learning architecture, which was developed by Lee Kohn in 1998, it was developed by the US Postal Department just to read or to automate the reading of the address of the code. So, and it was developed by the Bell's laboratory. And I'm trying to imagine this, just to pin code number where they would put all the letters just to separate out That means it is nothing but some classification problem. So this was the origin of the deep learning in 1998. Initially, first deep learning architecture was generated. So it has the deep learning approach. It has basically three layers, building blocks, basic building blocks: convolution layer, activation layer, and the pooling layers. Most of the deep learning approaches were based on the image-driven approaches. Initially, it was image, because in our human brain, we all store information in terms of image. Even we store the numbers in the form of image. That's why the origin of the deep learning was from the image-driven approaches. So main motive was that the pattern recognition techniques of the ventral visual pathway in the visual cortex of the mammals. Which was the main motivation. And the presence of constellation of neurons in the vicinity of a particular regions are only responsible for the entire field of vision. That when we extract information, we do not get the information for the entire image, rather from the part of the image we extract information. These biological informations are computationally implemented, and after that, though it was majority of the applications of the deep learning on the image base, now finally the deep learning is used for the signals also. So my concentration would be, with the help of signal, how we can use the deep learning, which is little bit unusual, rather not very common. So as I mentioned, it has how it extract the features, because it, as I mentioned in my earlier block, this is three major blocks are there: convolutional layer, activation function, and the pooling layer. So what is the function of the convolved features? As you know from the definition of the convolution, that if you have a filter, this is suppose a filter, and the green one, the pink one is, the green one is suppose the original image. Here I am represent the image in the form of binary image, that means with help of 1 and 0. And the orange one, this is suppose the filter. So as the convolution means, this filter is convolved over the images. As is convolved means it is convolved and multiplied, so it is multiplied, and within using this formula, just multiply and summing, convolve means multiply and summing, we are getting some convolved features. This one, next this one, multiply and summing, multiply and summing. So these are the features which are extracted from the original image. Now you see, if I change the size of the filter and the type of filters, then the extracted feature would be different. Now once this convolved features, we use some techniques which is called the pooled feature. Generally some statistical techniques like max pool, maximum operations are done. That means if I take these 4 features, we would take the maximum value. Here it would be, say, suppose 4. So in this way, we actually pooling operations are done. So these equations I have given, this mathematical equations is for the 2D convolutional neural network. Now, when we want to apply it for the signal, this is, we can think a signal is nothing but and 1D array. Is it not? Because 2D array means image means we can convert it to it has some row and column. So a signal we can think about as a 1D array. No, 1D matrix rather. So the equation would reduce to this value for the 1D signal. So here, I tried. This is very popular. You would get it anywhere. Just for suppose a car, when we are using it's a very convolution abstract, we are finding out that we are getting this kind of image from the higher level to lower level, because one convolution then pooled, then again convolution, then pooled. In this way, we would get to the fully connected layer where the actual classification is done. The major advantage or the major difference of the deep learning from the conventional machine learning is that here, instead of here the feature extraction and the classification is done in the same framework, and the number of layers, number of kernels, kernel size, and the pooling ratio, they plays a very important role. We call this at the hyperparameter tuning. These are varying to find out the optimum architecture for a particular applications. Now, as you see, and I have mentioned earlier that when we would apply, and the conventionally these deep learning architectures are used, deep learning is used for analysis of big data related to the energy management system. But this computation is really very much computation intensive. The conventional computer, it is very difficult to do it. Normally we use the GPU, GPS, graphics processing unit, GPU, but the power utility, they are higher the cloud. They are used in the cloud computing. Suppose you have the smart meter data, and the smart meter data are applied in the cloud for doing all these kinds of computations or algorithm. It may be used with the various kinds of deep learning applications, and the final decision what is coming, that would again come to the utility. So third-party cloud is higher. Google Cloud is there, IBM Cloud is there. They are just hiring those computation server there, just hiring. Now, what are the applications area where we can use this energy management system? That means, as I mentioned, the wide area situational awareness, power system security and protection, state estimation, power system event classification and detection, short-term load forecasting, big data-driven demand response. And all these kinds of things, you can apply these deep learning. Some work has already been done in the literature. So this is the basic schematic representation of grid data and big data analysis. So dynamically changing energy system with a large share of renewable energy and equipped with IoTs, and the smart meters and smart sensor data, they are fading. And the optimization and the machine learning data mining algorithms, they are used, and they can be used for these various kinds of activities and decision making. Here I would just like to mention some of the algorithms and their typical applications available in the literature. At the end, I would show you the references from where I have taken. Starting from the conventional neural network to k-means clustering to decision tree and the random forest artificial neural network, the RNN, recurring neural network, to long short-term memory, to the deep learning and convolution neural network, they have used typical applications like load forecasting, estimation of solar power prediction, fault detection and classification, short-term load forecasting, smart meter data analysis, and rotor angle monitoring. Now I am coming to a specific examples. First of all, I show the existing techniques in the literature, and then I would show that how it can more cost effectively or with less computation we can implement even with a low cost embedded platform, which we have done in our laboratory that I would show you. So this is the PMU based control and monitoring technique that I tried to show you in block diagram. That means we have the power system where we are assuming the renewable energy, so integrated renewable energy. So there may occur the disturbances, and the PMU is sensing the time synchronized measurement of the measurement, and these data are feeding as the input data. And this input data, phasor data concentrator, and where this decision making is going on with the help of machine learning or data driven technique, and some action is taken in the power system to make our power system self-healing. So how this kind of work has been done? This is a work done by a researcher in the literature. This data has given for the deep learning based grid event classifications based on the PMU data analysis, 3 kinds of disturbances they have taken. One is generated trip, another is load shedding, another is oscillation or the perturbation, continuous oscillation or perturbation. Now, as I mentioned earlier, that the origin of the deep learning was the image based approach. They first convert this signal or this patterns of disturbances, and here I would like to mention, I've forgotten to mention here, that these patterns they have showing for the phase angle. They have taken the phase angle, how the variation of phase angle pattern for the different kinds of grid events. And they have they first convert all these patterns, which are basically signals in nature, intentionally they have converted into the images. This signal is converted to this image, this signal is converted to this image, this signal is converted to this image. And this is one example I have shown. But they have created such huge data they have prepared, because as the model is learning itself from the examples, they are extracting features from the itself. They need a huge amount of training data. And using deep learning approach, as I explained earlier, convolution layer, then the max pooling layer, and finally they have done the classifications. So lastly, I am showing some example, some short video, 5 to 10 minutes video I am showing, where we in our laboratory solved a transmission line fault detection by 1D convolution neural network and implemented on embedded platform like a low cost embedded platform like Raspberry Pi. Just a minute, just share with me. I'm sharing, just a minute, just a wait. Let me share the video. Just enjoy the video. And if you have any question, please feel free to ask me.
Hello, madam. This is Navamita here.
Yeah, yeah. Hello.
Madam,
Hello.
in which platform the programming has been done? The CNN programming.
Yes, yes, yes. Yes.
In which platform, madam, the programming has
That,
been done?
and,
MATLAB.
no, Python first implemented, then Raspberry Pi we have implemented.
Okay. Okay. So the madam, the programming has been done in Python.
First in Python, we have developed the architecture,
Okay.
and then the trained network has been implemented in the embedded platform like Raspberry Pi.
Okay.
Just to show that it can, if we just optimize it and suitably select it, it is possible in the low cost embedded platform applications also.
Okay, ma'am. And madam, what is the source of data?
Actually, this is the simulation data, as she has mentioned, that IEEE 5-bus system, we have generated all these things.
Madam, the simulation, the data has been simulated in which platform?
MATLAB.
MATLAB.
Data has been simulated in MATLAB, and then this simulated data has been used to train the network, which has been, algorithm has been done in the Python. And once the architecture is finalized, actually this paper is under review. That's why I am not disclosing everything, because here we have, no, that much I can say, that we have developed our main contribution is that most of the application, the deep learning cannot be used for the real-time application because of its bulky architecture. But here we have optimized this architecture by a technique, by some optimization technique. That's why what the video is showing is that it is almost performing the same, but the computation has reduced to a great extent. So that even with our low-cost embedded platform like Raspberry Pi, we are able to implement it. And another thing is that instead of using image, we have used the signal. That's why the computation is reduced to a great extent.
Okay.
So that's all. Last one slide is there just for the conclusion part. I think I may stop here also. No problem, no issue. Thank you all for invite me and to share my ideas with such a big platform. Thank you.
Thank you, madam. Actually, the last presentation of your work has been very encouraging because I also belong to the same domain. So that is why I was very much interested to see your work. And so perhaps if I have any further queries, I may contact you later on.
Sure, sure. Actually, my scholar Shubhrajit Mitra, he is going to submit the PhD thesis. Actually,
Okay,
all credits go the hardware. He is very much expert in hardware part. Actually, and I have some group who are really expert in the software. So the combination of hardware and software both are required to this kind
Yes.
of work.
So, as I understand, madam, though I am not conversant with Python and Raspberry Pi yet, but as I understand, madam, that Python can take in the simulated data from MATLAB.
Yes, yes.
So, it
And
can be
we-
the simulated data from MATLAB can be interfaced with Python,
yes,
or rather,
yes.
it can take any kind of file as input.
Yeah.
Okay, okay, madam. Madam, today is the final day of our entire season of STTP, and you had been there in all the three sessions. So, for that, I'm thankful to you. And we have with us Professor Mr. Kunal, who is the Dean R&D of our institute present, as well as the professor of our department. So, I would request him to give the final vote of thanks to
Okay,
all of us.
okay.
Sir, please.
Honor, Honorable respected MD Sir, Mr. Taranjit Singh, Director, Sri Simarpit Sir, Principal Madam, Register Madam, for your kind support and enthusiasm to organize the STTP program in success. Our most valued invited guests, faculties, ladies and gentlemen, it is my privilege to have been asked to propose vote of thanks on this occasion. Our most valued invited guests, faculties, ladies and gentlemen, it is, I, on behalf of Narula Institute of Technology and sponsored AICTE, faculties, even special guests in the virtual audience, let me call it fraternity of IoT embedded distributed generations here together. And on my own behalf, extend a very hearty vote of thanks to all speakers for gracing your important work and sharing with us your findings and opinions. A big thank you to all speakers for their efforts towards their field of interest. I may like to express our sincere thanks to our Principal Madam and Register Madam for helping every time as and when required. I wish to express my gratitude to our HOD, faculties, staff members for their helping hand to make the event a great success. Lastly, I also thank to participants without whom the event could not be a success. We are all inspired by your great words. Thanking you all. Thank you.
Madam,
Yes.
thank you, sir, for delivering the vote of thanks. Madam, there is one question posted in the chat box. Uh,
Okay.
shall I raise that question, madam?
Yeah, sure.
Through deep learning, what I can understand from the writing is that how can deep learning can help to analyze transients in greed?
Yeah, it's very important. As I mentioned earlier, that the greed events, actually the transient disturbances, whether in terms of the phase angle or the voltage or others, any signals we take, we can think as a grid transients as a episode with a different patterns, as I mentioned. So, as a pattern recognition technique, the deep learning can be successfully used for the classification of grid disturbances. So,
Uh, Actually, madam, you have already shown the fault classification technique. So fault is also kind of
yeah,
transient in
yeah,
power system network. So
yeah,
therefore, deep learning can also analyze different kinds of power system disturbances. So it can be
yeah,
a useful technique in classification of power quality events that has
yeah,
not been done before with other techniques. So CNN can also be an effective method in dealing with them. I can
yes.
understand, right, madam?
Yes, sure. And one important thing that is that my emphasis is that in the majority applications, what we have tried to contribute is that majority cases in the literature, the people have tried to use the deep learning in the image processing. Even
Okay,
if
yes.
they have the signal, they have converted the signals in some method to the image. But whenever
Okay,
you are doing the image processing, its computation cost is high. So then it is very
yes.
difficult to implement it in the hardware platform. So our emphasis is to use deep learning in the signal applied to the signal, and also to optimize, because it is another technique how to optimize the architecture of the deep learning without hampering the performance, to reduce the architecture, bulky architecture, to optimize one so that we can easily implement in a low cost hardware.
পারমিতা, তোমার
Thank you,
সুন্দর
madam.
লেকচার হয়েছে,
Thank
লেকচার
you,
সুন্দর
sir.
হয়েছে পারমিতা।
Thank you, sir. আপনাদের blessings.
ম্যাডাম একটু সার্টিফিকেটটা শেয়ার করব, আপনি একটু আপনার প্রেজেন্টেশনটা কাইন্ডলি স্টপ করুন।
Sure, 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 sure. I'm sorry.
Okay, so on behalf of electrical engineering department, I am sharing the certificate of madam so that it is visible to all here. I will be sending the same to your mail as I have sent the earlier ones before.
Okay.
So I think it's visible now. Thank you,
Yeah.
madam.
Thank you very
And
much.
we have successfully come close to the end of the entire STTP, and it has been a huge task. And for this, I am grateful to all the faculty and staff, and of course you and the all the experts who have been with me. Without your participation, these programs could not be held. So I'm really thankful to you, and I hope that in our future programs also you will be with us.
Sure, sure, sure.
So
Thank you very much. It's my privilege also. I'm
okay.
honored.
Okay, thank you, madam, and good day to all the participants. And please, one thing I need to announce, I have already mentioned the chat box that there will be questionnaire, question MCQ based online test. The questions will be shared to you in the evening, and by tomorrow 12 o'clock in the afternoon, please submit the answers so that the e-certificates can be issued to you. So, goodbye, madam. Goodbye to
Goodbye.
all
Stay
the faculty
safe.
and staff
Yeah.
of my. Yes,
Bye.
madam. Thank you. Goodbye to all the faculty and staff of my department, our professors who have been with me for in all these programs. So, my heartiest gratitude to you, and of course to the entire college administration, our principal madam, our register madam, and to all the administration staff for their continuous motivation and support for all other activities of this short-term training program. So let us close this session of the entire season of STTP comes to an end. Thank you all. Stay safe and healthy. Goodbye. Stay safe and healthy. If you have any questions, please you can contact me or in email or phone numbers.